Not one border, two. Voyager 1 is moving through a place that should make perfect sense, and it does not. The sun still seems to reach for it even as the stars begin to claim it. Right now, a machine older than many parents is telling NASA the edge of home is not where anyone thought. If you like real mysteries that get stranger, the closer science looks, tap subscribe now. That way you catch the next story before the rest of the world stops scrolling and starts asking questions. Let's go farther. Voyager 1 began as a bold plan from the 1970s, back when computers were huge, memory was tiny, and the idea of reaching the outer edge of the sun's domain felt almost wild. NASA launched it on September 5th, 1977 from Cape Canaveral in Florida, and even that first step carried a strange twist because Voyager 1 actually launched after Voyager 2. Its path was faster, though, so it pulled ahead and became the first of the pair to race outward past the asteroid belt and toward the giant planets. It was built by the Jet Propulsion Laboratory, often called JPL, and it weighed about 1,592 pounds or 722 kilograms, which is about as heavy as a small car. And that small machine was sent to cross distances so huge that normal numbers start to feel useless, and somehow almost 50 years later, it is still talking to us. At first, Voyager 1 was not even meant to become a famous deep space ghost ship drifting between the stars. It had a simpler job, at least on paper, to fly past Jupiter and Saturn, take close pictures, and tell scientists what those giant worlds really looked like up close. But space missions often change when they succeed, and Voyager 1 succeeded in a way that shocked almost everyone. At Jupiter in 1979, it found a faint ring around the planet and discovered two small moons, Thebe and Medes, which had never been seen before. It also helped reveal one of the biggest surprises of the whole planetary era, active volcanoes on Io, the first active volcanoes ever seen anywhere beyond Earth. Then it rushed on to Saturn and made another close pass in November 1980, coming within about 78,000 miles or 126,000 kilometers of the giant ringed planet. It found 5 new moons there, along with a new ring called the G ring, and it showed that Saturn's ring system was far more tangled and delicate than earlier ideas suggested. It also studied Titan, Saturn's biggest moon, and found that Titan's surface was hidden under a thick atmosphere made mostly of nitrogen, around 90%. That mattered because nitrogen is the main gas in Earth's air too, and Titan's air also held methane and more complex chemicals that hinted at chemistry that could build life's ingredients. So before Voyager 1 ever became an explorer of interstellar space, it was already rewriting the map of our own planetary neighborhood. By 1990, the mission changed in a big way, and NASA officially turned Voyager 1's new job into what they called the Voyager Interstellar mission. That meant the easy part, if you can call flying past Jupiter and Saturn easy, was over, and the hard part was just beginning. Now the goal was to leave the familiar planetary zone behind and head toward the outer edge of the sun's influence, the place where our star slowly loses control. Scientists wanted Voyager 1 to find the heliopause, which is the boundary where the hot wind from the sun meets the colder material between the stars. In simple words, Voyager 1 was no longer visiting worlds, it was heading for the edge of our cosmic weather bubble. To understand why that edge matters, imagine the sun not as a quiet lamp in space, but as a machine that constantly blows material outward in every direction. That flow is called the solar wind, and it is made of charged particles, tiny bits of matter carrying electric charge as they rush away from the sun. Those particles help create a giant bubble around the solar system called the heliosphere, and that bubble stretches far beyond the planets. Inside it, the sun's magnetic field, its particles, and its pressure still shape the environment, even in the deep dark where Pluto travels. Outside it is interstellar space, the region between stars filled with different particles, different magnetic fields, and radiation from the wider galaxy. Scientists already knew Voyager 1 would not hit a solid wall marked with a giant sign saying you are now leaving the sun's territory, but they still expected certain clear clues when it finally reached that boundary. One clue was supposed to be the magnetic field direction, because the field carried by the solar wind should not point the same way as the field outside. Another clue was supposed to come from particles, with particles from inside the heliosphere dropping while galactic cosmic rays from outside jumped sharply higher. And one more clue, maybe the clearest of all, was supposed to be a direct reading of the surrounding plasma, which is hot charged gas spread through space. Before Voyager 1 ever touched true interstellar space, it hit another important zone first. In December 2004, at about 94 astronomical units from the sun, it crossed the termination shock, where the solar wind slows down hard after racing outward for years. 1 astronomical unit, or AU, is the distance from Earth to the Sun, about 93 million miles, so 94 AU is a distance so huge it is hard to picture. That crossing meant Voyager 1 had entered the heliosheath, the outer layer of the heliosphere, where the Sun still matters, but its power is weakening. And this was supposed to be a lead up to the big exit, a last strange stretch before the craft finally broke into the space between stars. As the years passed, Voyager 1 kept going and scientists kept building models of what the final crossing would probably look like. Most of those models pointed to a simple idea that when the spacecraft moved from the sun's magnetic field into the galaxy's magnetic field, The direction should swing sharply, not a tiny wiggle, not a small drift, but an abrupt change, the kind of switch that would make everyone at NASA sit up straight. And they also expected the particle balance to change fast, with the sun's particles dropping away and galactic cosmic rays, which come from beyond our solar bubble, rising strongly. By 2012, Voyager 1 was near 122 astronomical units, about 11 billion miles or 18 billion kilometers from the sun, and the long wait was reaching its moment. Then the first truly strange signs began. In May 2012, the number of galactic cosmic rays around Voyager 1 made a strong jump, while some of the lower energy particles from inside the heliosphere dipped down. On July 28th, the changes got even stronger, but after about 5 days, things slid back toward what they had been before. And that made the team think Voyager 1 may have brushed the edge for a moment and then drifted away from it again. It was like watching waves hit a beach in the dark and trying to decide whether the tide had really turned or was only teasing you. Then came August 25th, 2012, the date now remembered as the moment Voyager 1 entered interstellar space. The lower energy particles from inside the heliosphere dropped away so sharply that some fell by more than a factor of 1,000 compared with what Voyager had seen in 2004. At the same time, galactic cosmic rays rose to the highest levels of the entire mission, which is exactly the kind of change scientists expected outside the sun's protective bubble. If all you looked at were those particle readings, the case seemed almost closed, but science gets interesting when one piece of evidence says yes and another says wait, not so fast. Here's the detail that turned a big discovery into a full mystery. When scientists checked the magnetic field, they saw that the strength of the field jumped by about 60% at the boundary, but the direction changed by less than 2 degrees, which is tiny, almost nothing compared with what many models had predicted. That meant Voyager 1 seemed to be in a place that looked like interstellar space in some ways, but still looked tied to the sun in another crucial way. The border was not acting like a clean handoff from one ruler to another. It was acting like 2 domains were still touching. Why was that so shocking? Because the magnetic field was supposed to work like a signature, a clear mark telling scientists who controlled the space around the spacecraft. If the particle said Voyager 1 was out, but the magnetic field still looked almost lined up with the field inside the heliosphere, then the clean map in people's heads was wrong. This was not just one odd reading or one broken number on a screen. It was a sign that the border itself might be more tangled than expected. Ed Stone, the Voyager project scientist at Caltech, later said the path to interstellar space turned out to be much more complicated than imagined. Did you expect the biggest clue to say one thing while the second biggest clue said almost the opposite? If that twist catches you off guard, hit like and tell me in the comments whether you would trust the particles or the magnetic field first. And if you want more real space stories where the answer gets stranger after the data arrives, subscribe now. There was another problem, and it made the mystery even harder to solve. Voyager 1's plasma science instrument, the one built to directly measure the speed, direction, and other details of the plasma around it, had stopped working back in 1980. It failed just after the spacecraft's last planetary flyby, long before anyone imagined it would one day need that tool at the edge of interstellar space. So when the crossing happened, the team was missing the very instrument that could have given the clearest direct proof. Imagine trying to confirm you walked into a new country while your map is old, your road sign is bent, and your compass has lost one of its needles. That matters because plasma is one of the most important markers for telling where Voyager 1 really is. Plasma is gas whose atoms have lost electrons, which means the gas carries electric charge and reacts strongly to magnetic fields. Inside the heliosphere, that plasma mostly comes from the sun, and outside it comes from the interstellar medium, the spread-out material between stars. Scientists expected the plasma outside the heliosphere to be colder and denser than the hot, thin plasma inside the sun's bubble. So if Voyager could somehow reveal that denser interstellar plasma, the team would have the proof it needed even without the broken plasma science instrument. For months, the answer did not come from the missing tool at all. It came from another instrument, Voyager 1's plasma wave subsystem, which can detect vibrations in charged gas and turn them into something like a space whistle. In April 2013, that instrument picked up local plasma oscillations, basically ringing in the gas around the spacecraft, likely triggered by a burst of solar activity from the year before. Scientists think a major outburst from the sun, linked to the St. Patrick's Day solar storms, slammed into the material around Voyager 1 and made that plasma vibrate. Those vibrations rose in pitch through May, and a higher pitch meant a higher electron density, which meant the surrounding space was much denser than the heliosphere's outer layer. Then the team looked back through older data and found something even better. They found a fainter, lower frequency set of oscillations that had already appeared from October 23rd to November 27th, 2012, only a few months after the crossing. When they traced that weaker signal backward, it pointed to the same answer, that Voyager 1 had first entered that dense interstellar plasma in August 2012. In other words, the spacecraft had crossed into a new environment when the particle readings first screamed that something major had happened. The delayed whistle was like hearing thunder long after lightning and finally realizing exactly where the storm front had passed, and the numbers were not small. NASA said the dense plasma around Voyager 1 had a signature showing a density more than 40 times higher than what Voyager 2 had measured earlier in the heliosheath. That is the sort of jump that tells you you are not simply in a slightly different part of the same room. You have walked into a different environment entirely, one made from matter coming from other stars rather than from our own sun. And it was direct evidence that Voyager 1 was not merely near the edge anymore, it was bathing in material from the wider galaxy. So now the case looked stronger, but it also looked stranger. The particle data said Voyager 1 was out, the plasma density said Voyager 1 was out, but the magnetic field said the sun still seemed to have a strange grip on the region just beyond the heliopause. That meant the boundary between the heliosphere and interstellar space was not a neat, hard line like a border on a classroom map. And this is the part where the story stops being old history and starts feeling alive right now. Voyager 1 did not find a simple outside. It found a transitional region, a mixed zone, a place where the sun's influence fades but does not disappear all at once. Even after entering interstellar space, the spacecraft still detected signs that the solar bubble mattered there. So the shocking thing NASA did not expect was not just that Voyager would find interstellar space, but that interstellar space near our edge would still feel partly haunted by home. What would you have guessed before hearing that? A sharp wall or a messy overlap? Drop your answer in the comments. And if you like stories where nature ignores our neat diagrams, subscribe and stay with me for the next reveal. Because this next part shows the first surprise was not just a one-time fluke. In science, one strange reading can always be blamed on location, timing, or plain bad luck. Maybe Voyager 1 just crossed at a weird angle. Maybe that part of the heliopause happened to be unusual. Maybe the magnetic field alignment outside was a coincidence that would vanish if another probe crossed somewhere else. That is why Voyager 2 mattered so much, because it gave scientists a second crossing point, a second test, and a chance to see whether the first surprise was real. Voyager 2 reached interstellar space on November 5th, 2018. It crossed the heliopause at a different place and a different time in the sun's roughly 11-year activity cycle, which made it perfect for comparison. And when its data came back, it confirmed something deeply surprising first seen by Voyager 1. The magnetic field just beyond the heliopause was again found to be parallel or lined up with the magnetic field inside the heliosphere. That meant Voyager 1 had not stumbled into a weird one-off patch. The strange alignment looked like a real feature of the boundary itself. Voyager 2 also helped confirm more of the wider picture. Like Voyager 1, it saw the rate of particles from inside the heliosphere plunge. While cosmic rays from outside rose sharply and stayed high, it also showed that the plasma beyond the heliosphere was denser than the plasma inside, which scientists expected, but it also showed signs that the plasma was compressed. Voyager 1 had seen slightly higher than expected density just outside the heliosphere, and Voyager 2 found plasma outside that was slightly warmer than expected, also hinting at compression. In plain terms, the edge of the heliosphere looked squeezed and disturbed on both sides, not calm and balanced like a clean, quiet border. That detail matters because it tells us our sun does not simply blow a bubble and stop. The bubble pushes into the interstellar medium, and the interstellar medium pushes back. The result is more like a moving shoreline, a place under pressure, a place shaped by flow, force, and constant interaction. Scientists even compare the heliosphere to a ship moving through water, with the space between stars acting like an ocean around it. Voyager 1 was supposed to show us the open sea. Instead, it first showed us the rough wake and spray near the ship's edge. There was another twist that made the boundary seem even less solid. One of Voyager's particle instruments showed that some particles from inside the heliosphere appear to leak through the boundary into interstellar space. That means the heliopause is not a perfect shield. NASA described it almost like a hull that is somewhat leaky, especially in some regions more than others. So the line between inside and outside is not only blurry in theory, it is physically porous, letting matter slip through. Did you think the sun's protective bubble worked like a sealed shell? If this changes the way you picture our place in space, tap like and comment with one word for this border wall, shore leak, or something else. And if you want more stories where one old spacecraft keeps breaking modern ideas, subscribe before we keep going. Now step back for a second and think about what many people imagine when they hear the words interstellar space. They picture a silent emptiness, almost dead still, just black vacuum and maybe a few lonely atoms drifting around. But the space between stars is not truly calm. NASA scientists have said that thinking of it as quiet would be a mistake because it holds waves, turbulence, pressure changes, and signs of events from far beyond our sun. Voyager 1 did not enter a silent graveyard of space. It entered a restless environment with its own weather. A study published years after the crossing made that even clearer. Researchers found what may be the first continuous measurement of density in interstellar space using Voyager 1's plasma wave data. Instead of waiting for rare shock waves from the sun to trigger obvious whistles, they found a weak but steady signal, almost a single tone, changing over time. That tone seemed to track the density of the interstellar medium, giving scientists a more regular way to map the material around Voyager. And it was like realizing that the deep dark between stars is not mute at all. It hums, and that hum changes. And the team behind that work saw another surprise in the trend. Based on the signal, the electron density around Voyager 1 started rising in 2013 and reached its current levels around the middle of 2015. And that was roughly a 40-fold increase from earlier values, and then it stayed in a similar range with some ups and downs. So even after the famous boundary crossing, the environment did not settle into one simple fixed state. It kept changing in ways scientists could measure, which means Voyager 1 is not sitting in a static place, but moving through a structured region of space. And that matters for a bigger reason than simple curiosity. The density and behavior of interstellar space help shape the heliosphere itself, and the heliosphere helps shield Earth and the other planets from a lot of harmful cosmic radiation. NASA has said Voyager 1 showed that this solar bubble protects Earth and the planets from more than 70% of that radiation. So when Voyager tells us the boundary is compressed, leaky, and more complex than expected, it is not just describing a distant edge. It is helping explain the shield around the whole planetary neighborhood we live in. And here comes one more detail that sounds small at first, but changes the whole meaning of the mission. Even though Voyager 1 entered interstellar space in 2012, scientists were careful not to say it had fully left the solar system. That sounds strange, almost like word games, but there is a real reason. Many scientists define the solar system as reaching all the way out to the Oort cloud, a huge distant swarm of icy bodies still held by the sun's gravity. The heliosphere marks the edge of the sun's plasma bubble, not the full limit of the sun's gravitational reach. So yes, Voyager 1 is in interstellar space, but no, it is not completely beyond everything tied to the sun. NASA has said it may take about 300 years for Voyager 1 to reach the inner edge of the Oort cloud, and it may take around 30,000 years to get all the way beyond that cloud. That is the kind of timescale that crushes human instinct, because it means our fastest famous explorer is still, in a larger sense, only beginning the next part of its trip. The border we thought was final turns out to be one border among several nested inside something even bigger, and the future gets even stranger. NASA has said that in about 40,000 years, Voyager 1 will be closer to a star called AC plus 793888 than it will be to our own sun. Not Alpha Centauri, the star people usually mention first, but a different star because of how both objects move through the galaxy over long stretches of time. So this little machine built before the internet-shaped daily life is already on a path that will outlast countries, languages, and probably whole chapters of civilization. It is not just leaving a place, it is becoming part of the galaxy's long motion. Even now, Voyager 1 is still speaking, though it is doing so with less and less power. Over the years, engineers have turned off instruments to save energy because the spacecraft runs on radioisotope power systems that slowly weaken. Its cameras were shut down long ago, back in 1990, after the famous family portrait of the solar system and the image that inspired Carl Sagan's pale blue dot. In recent years, more instruments have been turned off in a careful order so the mission can keep going as long as possible. That means every bit of data coming back now is precious because it arrives from farther away than any other human-made object has ever gone. Think about the delay, too. When Voyager 1 sends a signal, it does not come back in seconds. Even years ago, these travel times were measured in many hours, and as the craft moves farther out, that wait keeps growing. A message leaves Earth, crosses the dark, reaches the spacecraft, and the reply takes ages by everyday standards to come home. So the team is not driving it like a car. They are sending requests into yesterday and listening for answers from almost a day away. That alone would make the mission amazing even before the science turned weird. And yet the science is the heart of why this story hits so hard. People often expect the shocking thing in deep space to be aliens, giant monsters, or some impossible object hiding in the dark. But sometimes the real shock is more powerful than that. It is the moment when a simple idea one smart people trusted for years fails when reality finally gets measured. Voyager 1 did not find a movie creature. It found proof that the edge of home is more tangled, layered, and alive than our models had prepared us for. That is why this mission keeps mattering right now. Voyager 1 is not only telling us about one old crossing in 2012, it is still helping scientists understand how our sun interacts with the galaxy around it, how our shield behaves, and what the nearby interstellar medium is really like. Every new clue changes how we picture the space that surrounds the planets, the dust, the comets, and us. And that means this is not just a story about a machine far away. It is a story about the conditions wrapped around Earth itself. If you were NASA, what would shock you more, finding the expected border or learning your border never really worked the way you thought? Tell me in the comments. Hit like if this changed your picture of space, and subscribe if you want more science stories where the truth is stranger than the headline. Because Voyager 1 still has one final lesson, and it may be the biggest one of all. The biggest lesson is that exploration does not only reveal new places, it reveals the weakness of our confidence. Before Voyager 1 got there, the heliopause was mostly a clean idea in equations and models. After Voyager 1 got there, it became a messy reality with overlaps, leaks, compression, mixed influence, and a boundary that refused to behave like a textbook picture. And that is the kind of discovery that changes science at its roots because it forces experts to rebuild the map instead of just filling in one blank spot. There's also something deeply human in the way Voyager 1 keeps going. It carries the golden record, a gold-plated copper disc with greetings in 55 languages, sounds from Earth, music, and pictures meant for any finder that might exist somewhere in the future. It also once turned back and took that distant image of Earth, the tiny pale blue dot hanging in a sunbeam. So while Voyager 1 measures particles and magnetic fields, it also carries a quiet message from a small world trying to understand its place. That mix of hard science and deep feeling is part of why the mission still grips people across generations. Near the end of a story like this, the numbers stop feeling cold. A launch in 1977, Jupiter in 1979, Saturn in 1980, the Interstellar mission beginning in 1990, the termination shock in 2004, the heliopause crossing in 2012, Voyager 2 confirming key surprises in 2018. Those dates add up to more than milestones. They trace a single long question humans have asked forever. What is out there once home finally ends? And Voyager 1's answer is beautiful because it is unfinished. Home does not end in one place. The shield around us is real but not perfect. The border is there, but it is not simple. The dark between stars is not empty silence, and the farther we go, the more the universe seems to say the same thing. Keep looking. Your first idea is rarely the last one. If this story stayed with you, subscribe, turn on notifications, and come back for the next mystery. Leave a comment telling me which detail shocked you most, the magnetic field that barely turned, the leaky boundary, or the fact that Voyager is in interstellar space, but not fully beyond the solar system. And share this with someone who still pictures space as simple, silent, and empty. Thanks for watching. I'm glad you took this journey with me. See you in the next one.